Good afternoon, everyone. Is everyone awake? Getting your coffee in? Haven't crashed yet? Like Josh was saying, I'm Ben Smith. I work for Pivotal Labs out of Boulder, Colorado. And before I start this talk, I want to share a few observations I've made on this trip, especially when it comes to some of the differences that I've seen between the US and Australia. So, potato gems. Does everyone know what this is? I don't know. We don't have these in the States. We do, but they're called tater tots. They're the little fried bits of potatoes that you eat in the morning. It's a little weird that they're gems, though, right? Because in order to consume a gem, you have to gem install it first. That's a little weird. And we all know that you have to be careful when you gem install stuff because you could be running malicious code. Everyone knows that, right? I think in general, tater tots in America are a little bit more secure than potato gems. But Australia definitely is ahead of the US in other areas of security. For example, your ATMs here actually have guards. This was at Manly Wharf yesterday. I was worried he was going to steal my PIN, but it turns out he was just protecting me from mice or something. I don't know. But I'm not here to talk about security, Ruby gems, or even potato gems. So who saw my talk last year? Nice, good. Last year I talked about all that good stuff, all that security and gem stuff. I'm super happy to be back this year. And I'd like to thank everyone for having me back. I feel great to be back, and I'm happy to be here again. I especially want to thank the organizers for having me back and making it possible for me to make the trip over. Thank you so much. This year, I'm going to talk about architecture in Rails. And you might say that Rails has its own architecture and that we don't have to worry about it too much. And Rails does use a design pattern that we all know and love, MVC. But once your app gets big enough, relying on just the Rails way of doing things might get you in trouble. So I'm going to tell you a story about a Rails app that we tried our best to architect for success. And what does success mean? What does it mean for a Rails app to be successful, for a product or for a client? Well, in this case, we knew our project was going to be a long one. It was going to last 8 months or longer, which for Pivotal Lab standards is a big chunk of time. The majority of our projects last 3 to 6 months. We knew we'd have a large development team. It was going to start off with just 2 Rails devs and then ramp up to 10, as well as 4 iOS devs. And we knew that in 6 to 8 months, we'd end up with just a ton of code, given the number of devs we had. And this particular project was a from-scratch rebuild. The client had an existing code base and tool set, and their goal was to replace all of that with a new code base, as well as add some new features on top of it. And we knew to get that existing feature set parity, we'd just end up with a ton of code. The client also wanted to make sure that we had scalability in mind. Not that it needed to handle thousands of requests per second day one of launch, but that we had it in mind, and at some point in the future, it could handle load like that. And lastly, the client wanted to replace their entire old code base all at once, so a big bang release. This isn't something we normally do, but we worked with them hoping we could release a bit sooner than when it's all done. So what does success look like in these terms? Now, normally I'm all about doing the simplest thing possible, so I suggest you take this talk with a grain of salt. What I'm going to show you is not a silver bullet. It will help you in some cases and only complicate things in others. And I'm also not an expert on this subject. I'm just some guy that spent some time trying some things, and I'm going to talk about them today. So success. With these constraints, we knew we wanted to think about architecture from day one. So our first decision was to use Rails engines. Kinda. We decided to use Rails engines, but not in the normal way you usually see them used. Who knows what a Rails engine is to start? Okay, a good number of people. A quick intro to engines. Engines will allow you to take an entire Rails app. So models, views, controllers, CSS, JavaScript, everything. Bundle it up, and then you can require it as a dependency and potentially turn it into a gem that you can reuse in other apps. So Devise is a great example of an engine. Who knows what Devise is? Has everyone heard of that? Great authentication engine. The engines that we created for this project were a little bit different than Devise. They were never built into gems. They were never pushed to Ruby gems. Not only that, they never even had their own Git repo. All the engines we created went under our normal Rails source tree, which meant, for all you crazy SOA advocates, we didn't have to worry about things like versions of interfaces or separate deployments. All the engines I'm going to show you today lived inside of a single Rails app, and they were deployed and versioned together. Of course, you might ask why use engines in the first place. And we decided early that there were a few distinct components to our app that we could separate out into their own engines. But let me give you a little background first so you can understand why. The product itself was a content publishing platform for things like video, audio, blog posts, tweets, Facebook posts, SMS, everything you can think of. On top of that, it included a full social network with all the bells and whistles. And the content was consumed via an iOS app fed by a JSON API, and the content was created and moderated via a web interface. So that doesn't sound too complex, but we were focused on architecture. So we took our simple Rails app and started to break it apart. And in this diagram, you can see we have our Rails app, and inside of it, we have 4 engines. And the arrows point in the direction of the dependencies. And I'll refer to this main Rails app that includes the engines as the wrapper Rails app from here on out. So on the left there, we have an admin engine. This is where the content was created. Videos uploaded, blog posts written, things like that. On the right side, we have the social network. This is the user-facing content in the form of a JSON API consumed by our iOS app. We also created a common engine. And in here, we put things like users and roles that were required by both the admin and the social network engine. And at the top, we have another engine called the scheduler. And this engine was in charge of publishing this content. So the admin could create content, and it would get copied over the social network or posted out to a web interface like Twitter whenever it was scheduled to go live. And going forward, I'm not going to draw this box around all the engines. Just assume that all the engines I show you are within a single Rails app. And remember, the arrows point in the direction of the dependencies. So the scheduler depends upon the admin engine, the common engine, the social network. And the social network just depends upon common, and common doesn't depend upon anything. Does this make sense to everyone? Because it's about to get more complicated. So the next thing we did was we wrote a gem, not an engine, but a gem, to wrap an SMS service called Mobile Compass. And we chose to make this a gem instead of an engine because it didn't need a database connection, it didn't need the asset pipeline, or anything else that Rails and engines give you. And I made Mobile Compass here red, so you can see it's not an engine like the rest, but just a gem. And in this architecture, we wrote quite a bit of code. But as we got farther into building this application, we realized there are specific users of the system that we could create their own engines for. Specifically, we realized that there were more than one type of admin. There's a global admin who could do things like CRUD users, and then a content admin whose sole purpose was to create the content, like write blog posts. So we broke these two out into separate engines, and we had them both depend on an admin assets engine. And admin assets contain things like layouts and styles that both of the admin engines used. Once we realized that it made sense to split out engines based on roles in our system, we created another admin engine called the social admin. Social admins were moderators of wall posts, status updates, or any other user-generated content. And we felt pretty good about this. We were identifying engines, and we were keeping our app broken up into smaller pieces. Then we had a breakthrough. And it actually wasn't us. It was our office director who walked by, and he said, "Your social admin engine depends upon too much. It doesn't need a dependency on things like the controllers in the social network engine. All it needs are the models." Now remember, the social network engine is this user-facing JSON API. The social admin is an admin web interface to moderate things like wall posts and status updates. The models for wall posts and status updates live inside of the social network. And it took me a while to come around to this idea, but you did have a point. The social admin engine depended upon all of the social network, which means that it has references to things like controllers or views, which just aren't needed. And keeping your dependencies to a minimum is always a good idea. What we really wanted was to just depend upon the models of the social network. This would allow us to create controllers and views to moderate things like wall posts or status updates. So we went back to our engines, and we did a refactoring. We pulled the models out of the social network and put them into an engine called social network content. We renamed social network to social network API because now it truly was just an API. It contained controllers and presenters, but it didn't contain any models or domain objects. And finally, we added a dependency from the social admin to social network content, which, going back to the original problem, allows the social admin to only require what it needs. So instead of having this, we have something that looks like this, which addresses our original problem of requiring too much. And we thought, why stop there? We actually have this same problem in our scheduler engine. It was requiring all of the content admin engine, but all it really needed was the models inside of it. So we split out the content admin engine into content admin elements. We updated our dependencies. And at this point, we started to notice a pattern here. We had some engines that could respond to HTTP, engines with routes and controllers. And we had other engines which only contained models or business objects. So we started calling them web engines and domain engines. And here you can see I've color-coded the web engines as blue and domain engines as brown. And as a team, we found that identifying these patterns and putting names to them is really helpful. Because once you identify a pattern and name it, now you can think of in terms of what makes sense for that given pattern. For example, if someone told me, let's add a user's controller to our common engine, I could say, no, that doesn't make sense because this is a domain engine. It shouldn't have controllers. But speaking of an engine called common and of patterns, we realized that having something called common is a bad idea. Common means you can put whatever you want in it. It's like the lib folder in Rails. So we renamed it to what we wanted it to be, users. And once we renamed it, we realized there was stuff in there that shouldn't be in there, specifically a profanity filter. So we pulled that out into an engine. And from here, we did some more work and some more work. And this is where we ended up after about 6 months of development. We kept on working on the app, but it just keeps getting more complex and crazy and harder to draw. So I'm just going to stop here. So how does this look? First word that comes to mind. Hell? Drawing this diagram like this makes the app seem crazy, right? Like it would be impossible to work in. But here's the hard part to understand. The complexity is not because of the engines themselves. The complexity is part of the domain of this application. We would have the same dependencies and the same crazy mess if we didn't have engines, but we wouldn't be able to talk about them or see them visually. And in reality, you really don't need to know that entire graph by heart. You only need to focus and understand some subset of that graph. And there's also a general pattern to these engines. And that general pattern is that web engines depend on domain engines that depend on the database. And if you think about it, that's not far off from your standard Rails stack that has controllers and views depending on models, depending on the database. So as crazy and scary as this looks, it's not far off from your standard Rails stack. And if you don't believe me, there's my Twitter handle in the bottom left-hand corner. Go ahead and tweet at me, heckle me on the internet. So here's the craziness of engines. So now you're probably asking yourself, how do I get there? This looks great. So I'm gonna show you how to get started with engines just really quickly. And don't worry, all these slides will be posted online, so you don't have to write this down. This is how you create a Rails engine. You run this from the root of your Rails app. This is how you require it in your gem file. And you can require one engine from another engine, or you can require an engine in your wrapper app. And then if it has routes and controllers, this is how you mount it. If you want to create a gem instead of engine, it's as easy as this. Same thing to require it. And the next step, after you start creating these engines, creating these gems, is you actually want to just run this once and create an engine template. So once you create an engine template, all you need to do is copy and paste that engine template anytime you want to create a new engine. Do a global find and replace on a couple of strings, rename a few files, ideally in some sort of script that you write. And this gives you a standard engine template to build off of. So if you want to have some standard basic dependencies or setup in your template, you can do that once. For example, if you want to standardize on using RSpec or HAML, you can do that in your template so that any engine that you create from there on out is going to have those libraries in them. The same thing applies to plain old gems. You want to create a template to build off of. And the point here is to really lower the bar to create a new engine or a new gem. You want to get to the point where it only takes a couple of minutes to create a new engine, and it cannot be screwed up. And the idea here is we found that it was easier to take two pieces of code and merge them together later, rather than have one big chunk of code and decide later that you want to try to split it apart. So if you always try to start with the code separately and then have to merge it together later, you're going to be in a better spot in the long haul. So got all that? That all makes sense? All the slides will be posted online, don't worry. So let's get back to the interesting stuff, doing engines the right way. From the beginning, we decided that engines to be completely self-contained. And for us, this meant database table namespacing, putting the migrations inside the engines themselves, and having all the tests contained within their respective engines as well. So let's talk about each of these. Database table namespacing. So with this architecture, we wanted these clear and real boundaries. We wanted boundaries almost as real as if you were doing full SOA. So if you took our simple week 1 architecture and you converted this to SOA, it might look something like this. And this is what we wanted to mimic. Messages over HTTP, separate databases, different Rails apps. But we wanted things simple and easy. We wanted one database, we wanted messages in Ruby, and we wanted engines instead of apps. So we took our engines with their single database, and we chose to namespace all the tables in that database. So each table was prepended with the name of the engine that belonged to. So moving from this to this would mean putting each engine in its own wrapper Rails app, breaking out the database tables by namespace, and adding a small wrapper so you could send HTTP messages rather than Ruby messages. The other cool thing about being able to pull out an engine into its own app like this is that you could actually scale that app on its own. For example, the social network might need to handle a lot of requests compared to the admin, which may not need to handle barely any. So putting the migrations inside of each engine was another thing we decided to do. And the interesting thing here is Rails doesn't fully support this out of the box. It does sort of support it, but not the use case that we wanted and that we were using. The case that they support is the one like devise, where you have a gem and you want to use that gem and that engine in multiple apps. And in those cases, you run something like this, rake install migrations, and it copies your migrations out of the engine into your wrapper app where they can be run. This works fine if you never add new migrations to your engines, but if you're adding migrations and changing things, this becomes a pain. I don't want to talk about this too much, but here's the monkey patch that allows you to leave your migrations inside of your engines. And here's a blog post on how it works. The last thing I want to mention about migrations and engines is it's best to have each migration only touch one database table at a time. And the reason for this is that if your migrations only touch one database table, it becomes trivial to move tables between engines. It basically boils down to you cut and paste all the migrations from one engine to another, rebuild your test database, and you're good to go. And there's more info here. This is kind of a crazy idea, though. If you think about having a full service and you want to move a database table from one service to another, that could be very difficult. But in this case, it becomes trivial. The final self-imposed constraint that we put on engines was testing the engines in isolation. This means the tests for the engine's functionality actually live inside of the engine. And when the tests run, they only require the one engine that they're testing. And they prove that the engine is self-contained. It doesn't use anything that's not explicitly required. For example, if you put your tests for the admin engine inside of the engine itself, you can prove that there isn't any code in your admin engine that references things in the social network. Whereas if you put all your tests in your wrapper app at the top level, you can't prove that because your wrapper app loads all of these engines together. So going back to doing engines the right way, these were the things we felt were necessary for keeping everything inside of each engine clean. But outside each individual engine, we also came to some conclusions on how engines should interact with each other. Not having circular dependencies was key for us. Having circular dependencies in general, make it much harder to refactor later. And if you look at our dependency diagram here, there's no circular dependencies. This is a directed acyclic graph. And if there is a circular dependency, it's just because I drew it wrong. As a general practice, we decided that whenever it seemed impossible not to have a circular dependency, it meant that we were trying to split things apart too much. So if you have two engines, A and B, and it seems like there's a circular dependency, what you probably want is an engine that is A and B combined. But whenever you can avoid doing this, you should. And in Rails, it's super easy to create circular dependencies. Something like this is super common in Rails. User has many posts, post belongs to user. It's easy to do, but it makes your application harder to refactor when it gets big. This type of code will result in a circular dependency between users and posts. Each one references the other. So how do you avoid falling into the circular dependency trap? Well, you could stop using ActiveRecord associations. And how do you stop using ActiveRecord associations? Well, you could stop using ActiveRecord. We didn't quite do that, but we did something along those lines. The approach we took was to create a domain API layer or a service layer, just a layer between our controllers and our models, an interface to our domain logic. And all our domain API was, they were simple Ruby classes to wrap ActiveRecord calls. The arguments to the methods were just simple IDs or params, and the output was always plain old Ruby objects. So let's take a look at an example. So here's a simple example of a domain API class called the user manager. And we have a method here called find user by ID. It takes an ID, finds a user. And to do this, it calls userRecord.find. And userRecord, if you look below, is an ActiveRecord class. And you'll notice that the class is defined below the private line, meaning that it should only be used within this user manager. The ActiveRecord user is passed off to user.new, which copies the attributes off the ActiveRecord class and onto itself. And here we could actually just return the ActiveRecord object if we wanted to. But we wanted to deter people from using ActiveRecord as much as possible. So if you return just a plain old Ruby object, like this user object here, the caller of this method can't do things like call update attributes or .posts or .delete or any other ActiveRecord calls that we don't want to expose. And this is a real simple example. Probably what you'd want to do is metaprogram this a bit, metaprogram the copying over of the attributes, use things like active model or active naming so you can get the form and URL helpers from Rails. But in general, this is a simple example of the pattern we used. And this is a brand new design pattern that I came up with. I call it the Ben's Awesome pattern. So please tell all your friends about it. So how does having this domain API affect this situation? Well, in this situation, there's two possible things you might want to do. Given a user, we might want to know all the posts they've written. Also, given a post, who is the author of that post? So if we were to write a domain API to handle both these cases, what would it look like? Well, the first case, given the user, we want to know the post. It would be as easy as creating a find all by user ID on a post manager. And with this method, we could do something like new up a post manager, call post manager.findAll by user ID, pass it the user ID, and that gives us back the posts. And this handles the case of knowing the user and wanting the posts, which means we don't need this line. User no longer has a dependency on posts. When we want to know the post for the user, we're going to the post manager. Now, if we start using our user manager, we should be able to do something like this. New up a user manager, given a post that has a user ID attribute, find me the author of that post. Now, the crazy thing here is using these domain API objects, there's no real code dependency between users and posts anymore. There is a dependency there because post has a user ID, but the important thing is there's no circular dependency. The other great thing is that user doesn't have to change when we add posts to our application. And the same applies when you add other things. So if you add comments and videos, user still doesn't have to change. You'd be adding small domain API objects for each of those things. So you'd have a comment manager and a videos manager. And all of those things depend on user, not the other way around. Now, who's seen user models in Rails apps that are hundreds or even thousands of lines long? Just gigantic. It messes, right? A good number of people. This pattern completely avoids having those huge classes or those God objects. Instead of having a few huge classes in your application, you end up with a bunch of small ones that are loosely coupled and easy to refactor. So how does circular dependencies, or the lack thereof, affect our engines? Well, reducing the number of necessary circular dependencies lets us go from a single Rails app where everything references everything else to a Rails app where things are all broken apart into engines. Because like I said, if you have a circular dependency, then you should group those two things together. And if you have a lot of circular dependencies, you're going to have a lot harder time breaking things out. The other great thing about having engines and an acyclic dependency graph is you can create a smart and fast test suite. So imagine you're working within an architecture like this. And say you're making changes to the admin engine. When you run your tests, you don't actually need to run them for all the engines. All you need to do is run the tests within the admin engine and the tests within the scheduler. Because the scheduler depends upon the admin engine. So potentially changes made in the admin engine could break things in the scheduler. But you don't need to run your tests for the social network or the common engines. We didn't make any changes to those engines, and we didn't make any changes to the engines those engines depend upon. So you can write a smart test suite using something like getWhatChanged, which lists what files that have changed since your last push. And you can determine what engines have changed and what engines need their tests run based on your dependency graph. And what we found is normally you only need to run a fraction of your tests. And we have our one-way dependencies to thank for that. Because like I mentioned, things like the user engine, which is heavily dependent upon by the rest of the system, rarely changes. The example with users and posts, when we add posts to the system, user doesn't actually have to change. So you don't have to run the majority of the tests in your app. So how did using engines, domain APIs, and all these conventions work out for us? Well, engines are a pain. In the beginning, we had super low velocity for the first month and a half. The client was actually getting worried. And we really couldn't bring on more developers, more firepower, because we were still developing these patterns and best practices for engines in our application. And constant refactoring was a must. At one point, we were spending about a third of our time just refactoring. And there was a few technical hurdles we had to overcome, the monkey patching of Rails being one of them. But over the long term, engines definitely went out. At the end of 8 months, we saw no slowdown in development time or the time it took to do fairly major refactorings. Engines age really well. Oftentimes, we'd finish working on an engine, and we could ignore it for months at a time after that. It makes for easy parallel development, so you have these little boxes that certain teams can work within, and you can talk in terms of which team will be working within which engine. And the potential for scaling is great. If you need to scale a certain area of your app, all you have to do is pull that engine out into its own app and scale that individually. And lastly, you can write fast tests. So overall, I give this architecture a thumbs up, but it probably took me 2 months to really come around to it. I really hated it for the first month. So if this stuff seems interesting to you, or if you think it might help one of your current apps, give it a try. Try creating a new engine for the next major feature you add, or try pulling out some of your models into their own engine. Try avoiding circular dependencies, creating a service layer. But most importantly, try to think outside of the Rails way of doing things. Try to think in terms of what makes the most sense for your app. Like Cam said this morning, build the right thing the right way. Start thinking in those terms. Thanks. If you want to learn more about engines, my coworkers and I have been blogging a bit about engines, and here's a link. There's also a link to my speaker deck. I'll post these specific slides in a few minutes. That's it. Thank you.
Awesome. Thank you very much, Ben. Do we have any questions? We do.
Just wondering what kind of tooling you were using to establish your dependencies, to make sure that you weren't planning certain dependencies and
a whiteboard and a dry erase marker. But I mean, we pretty much went fairly low tech on that. And it was actually kind of a good exercise in our process. Anytime someone added a new engine, they would erase the whole thing and redraw it, which made sure that everyone on the team knew how everything was interacting. And when you redrew it, you would be looking through the gem files and making sure, hey, there's no circular dependency here. So that's the approach we took. We kind of took the process approach on that.
Okay, we've got another question over here.
Sure.
I really like the idea of splitting out the tests into the different engines. That was really well done. Did you also have tests overall for the entire application to make sure everything tied together, or
we did have some tests, and those tests lived at the highest level, so they lived in the wrapper app, and they tested to make sure that data was moving correctly between each of these engines. And there was a few of them there, kind of like our high-level smoke tests, so to speak. Yep.
Cheers.
Thanks.
Yeah, up here.
Thanks for the good talk. I just got a question. You said at the beginning try to split the app into the engine as soon as possible, so you wouldn't have any problem splitting them to engine later on. What are the general rules? Do you have any advices when, in terms of design, how we should split the app into engine at the very first start? Because I find more sort of like premature optimization, try to do things, in-term architecture at the beginning when we're quite clueless. Not clueless mean not fully get the whole picture of the app, because normally the presets won't fit you everything at the beginning, right?
So that's a hard question, trying to decide where those seams are that you should break apart your app, right? That's the general question. So we started by kind of looking at a high level. What are the big areas of your system, either big areas of functionality or the users of the system? That's how we started breaking things out. I've also explored kind of breaking things out at the lowest possible level, so where I'll have an engine, and there's actually a couple of engines in this app where the engine only contained a single model and a single database table, and that was it. Really, really small. And I think it really just kind of depends on your application and your team, what you're comfortable with. It doesn't really, it's not really a good answer, but the best answer I can give you is it depends. And I'm happy to talk with you more after, too.
Okay, I've got one over here.
Was each engine in its own code base and included as a gem, or just wondering how you structured it?
They were all under the same code base, so we had a single Rails app, a single source tree, and then we had a subdirectory that was engines right next to like the app directory or the lib directory in the Rails source tree. And that's where we had all of our engines underneath that.
So I was just wondering how you got your tests to fire. Say you modded just one engine. Like, were you able to just run the test for that one engine on a commit?
So Rails gives you it's called the dummy app, which is it's actually a full Rails app inside of your engine that requires the engine itself. So you can boot up this little dummy app that requires this one engine that it's inside of, and then you can run your tests just within that context. Yeah, that's basically in a nutshell how it works.
Okay.
Just if you stop exposing ActiveRecord objects to your Rails application, don't you find it hard to work with forms or even optimizations like including relationships?
It is harder to not use ActiveRecord. ActiveRecord makes things really easy. It also makes your code really tangled. So it's a trade-off, right? People who have written code before there was Rails, you know, this is stuff we had to do, right? We had to write all these functions, all these methods to do these things. On the other hand, it's a little bit of a balance because things like the form helpers to get everything to work well in your views, you can get some of that using parts of Rails. So I believe it's active naming and active model you can include into your objects that get returned. And it doesn't expose all the ActiveRecord stuff, but it still gives you a lot of those helpers that make things easier to get, you know, data back and forth from your views. So it's a little bit of a balance there.
Awesome. We've got time for one more question.
A comment and a question.
Sure.
The wonderful thing about new frameworks is getting to discover the same problems again and then invent the same solutions again. Large software systems have had to deal with this problem, obviously, for a long time. What I wanted to ask was, were you using foreign keys? And if so, how were you dealing with foreign key relationships between different engines?
So foreign keys is kind of interesting, right? Because you have tables that live in different engines, right? They don't necessarily know about each other. But there's two solutions that we had in this architecture. So one was if there's two things and we needed that performance boost, one option was to merge the two of them together. And we did that in one place where we said these two tables really should be together. We need them to be performant. We need foreign keys. You know, we need all this stuff. So pull these two things together. The other option is you have these two separate things, right? And then you have something above it that depends upon those things. And that thing above it is what creates that join in between the two. No, not well, so there's a little bit, you can enforce them, right? So you can add the foreign key, these constraints at this higher level, right? But it's a little bit of a gray area that we toyed with. Yeah.
Awesome. Thank you very much, Ben. Everyone, big round of applause for Ben.